Example 8. Find the equation of the tangent line at the given point on the curve. 3y squared minus the square root of x equals 23, and the point is 16.3. Well, to find the formula for the slope of the tangent line, we need to take the derivative, and since it's not solved for y, we'll need to use implicit differentiation. So the derivative with respect to x, 3y squared, minus the derivative with respect to x of x to the 1/2, so I'll go ahead and write my square root as x to the 1/2, equals the derivative with respect to x of 23. So for this first term, the derivative of 3y squared will be 6y, and the derivative of y is dy dx, minus the power times the base to the power 1/2 minus 1. And then, of course, the derivative of a constant is 0. So 6y dy dx minus 1/2 x to the negative 1/2 equals 0. That's 6y dy dx minus 1 over 2 times the square root of x equals 0. So because this is a negative exponent, I move that base to the denominator. It goes along with the 2, and the 1/2 power is a square root, so I went ahead and just wrote it as a square root. Now solving for dy dx, 6y times the derivative of y with respect to x equals 1 over 2 times the square root of x, and I need to divide both sides by 6y, so dy dx is 1 over 2 square root of x times 6y. So let me show you how I got that when I divided that. So 1 over 2 square root of x divided by 6y over 1. So it's like it's a whole number. So 1 over 2 square root of x, and the rule for dividing by fractions is to multiply by the reciprocal. So you'll notice that the numerators are both 1s, and then the denominator is what I get when I multiply 2 square root of x times 6y. And that's true anytime you divide a fraction by a whole number, that whole number ends up being multiplied by the original denominator. Do a little bit of reducing here. Dy dx is 1 over 12y square root of x. Now you can put the y in the back, but you have to make sure it's not inside the square root. Now this is the formula for the slope of the tangent. And we need to evaluate that at the given point, which was 16.3. So we'll put in a 16 for the x and a 3 for the y. So the derivative of y with respect to x is 1 over 12 times 3, the square root of 16. So dy dx is 1 over 36 times 4, or 1 over 144. This is the slope of my tangent. So now, using the formula for the equation of a line, y equals mx plus b. I'll substitute all the parts I know. Y is 3. M is 1 over 144. X is 16 plus b. So 3 is 16 over 144 plus b. That fraction reduces to 1/9. So 3 equals 1/9 plus b. So 3 subtract 1/9 is my b value. I need a denominator of 9. So I need to multiply the first fraction top and bottom by 9. So that becomes 27 over 9 minus 1 over 9 for my b value, which is 26 over 9. So the final answer for the slope of the tangent is 1 over 144. For the b of the tangent is 26 over 9, which makes the equation of my tangent line to that curve at the point 16,3 is y equals 1 over 144x plus 26 ninths.